Right, we're finishing up with the angle side piece of 3.2. Scrolling down. Excuse me. So we're looking at the examples in 3.2, all right? And going to example 1, it's asking us, or it's telling us, right, the information from triangles below looks to be an angle side postulate. So let's figure it out. How can we figure that out? So taking a look at these triangles, you know, I got a side of 6 here, and I know angle A, and I know angle C. All right, so let's take a look at the other one. Ooh, interesting, it's got a 6 here as well. I also know angle D and angle F. So I've got 2 angles in each one of them. Let's just take a look at the values and see if they line up at all. Ooh, they do, 66 and 58. So that's fantastic. We have 2 identical angles, and we have 1 identical side. So let's see if an angle side logically will make sense. All right, if 180 degrees, right? Our triangle adds up to 180 degrees on all of the interior angles. And if I add up 66 and 58, let's just do a little calculator action here. All right, 66 plus 58. All right, 124. All right, so 180 minus 124, 56. Cool. So I know that E has to be 56 degrees, and I also know that means B does too, because these angles are exactly the same as well. All right, cool. So if the angles are all identical within it, the only thing that's constraining me is the sides, right? Because I could dilate, right? I could make one of these really big, and it would still share the same interior angles. We would just have bigger sides. So the question is, are these two congruent? Are they the same? And how can I prove it? Well, hey, if one of my sides has been specified, right, everything else kind of has to be locked into place, all right? If this is 6, I put a 66 degree measurement here and draw a line. Say it just goes on forever, or a ray anyway, all right? And then I also have the 58 degree angle, so I have the 54 degree angle at this point, so I can draw a 54 degree angle at E, right? Draw a ray that goes on forever. I could measure these two sides, and if I did the same thing with BC and AC, all right, I would wind up seeing where the two rays cross here. They have exactly the same length, BC, AC, EF, DF. All right, so we'll play with that in class, but that's the basic idea of why an angle side should work. All right, cool. Moving on to this example 2, we have some ways in which the congruence is demonstrated through just symbols. All right, so we know that this angle, we have no name for it, but this angle right here is corresponding to this angle, and we're told that because these two like arcs here match up. Same with this one arc up here, so these two line up. And then we also have, all right, this particular side that is identical between them. So I have an angle, a side, and an angle. I can conclude, or at least I could figure out that if this is the same and this is the same, if I added those two up and I added these two up, they'd be the same number. And then out of 180, right, if I subtracted that number from 180, I should get the same exact amount for this one and this one. Cool, so I got all the interior angles. That's beautiful. All right, now I just need to confirm that I have a side, and then everything locks into place. I do. Angle, side, angle. These two sides are congruent. These two sides have the same length. I'm good. All right, these triangles are congruent by angle, side, angle. All right, let's look at example 3. Are the following triangles congruent? Let's figure that one out. All right, it looks like we have this double tick mark here. That's another way of notating it. And another one right here that's identical. So E should map to C. All right, now let's see what other information we have. We have a tick mark here on a single arc, and right there, so F should map to B. Gorgeous. We have FE being the same as AB. Oh, well that's interesting. Okay, and I can see here that FE is bigger, right, than GE. All right, and it's going to have to be just because these two are cute, right? So it's going to kind of bring two rays in, and they'll kind of cross right here when those two rays kind of wow, wow. They would cross right there at that point. Same here, wow, wow. All right, and oh, excuse me, wow, wow. Anyway, we actually are seeing the problem here. If this is the side that I know here, and this is the side I know here, and those two are equal, uh-oh, that's not going to work. So we cannot prove that this one is congruent. There's not enough information here. All right. Let's move on to 4. Are these guys congruent? Let's take a look. All right. Looks like F maps with B, and it looks like FE maps with BA. But this could go on forever. This could go on forever. I could put a C and an A anywhere on one of those rays, and that would make AC, and the corresponding one that would possibly go with that would be GE. They could be totally different numbers. All right. So you would need to know at least one more angle, all right, or one more side. All right. So probably would need to know angle A. All right. And then you would need to know that angle A and angle E are congruent, and then you could assume that the two triangles are congruent. All right, awesome. I hope that really helps.